Hi dear students. So in the last class we have discussed about the average velocity and average speed. So now let us come to the position time graphs of a body at rest, a body in uniform motion and a body in non-uniform motion. So first of all, consider a body at rest. So here you can see the position is given on the y-axis and the time is given on the x-axis. Body at rest means if the time changes, then also there will be no changes in the position of the body. That means the body is still. Okay, that is at rest. It is not moving. So for the first 10 seconds the body is at 40 meters. After 20 seconds then also the body is at 40 meters. Again 30 meters at 30 seconds it is at 40 meters only. In such a way you will get the graph as a straight line which is parallel to the x-axis or the time axis. Okay, so where the time is changing but there is no changes in the case of the position of the body is not changing, that is constant only, that is the body is at a rest. Now let us come to the body in a uniform motion. There also the xt graph it is, so x is in the y direction, y axis and t in the x axis. We know that for a uniform motion, for equal interval of time, there will be equal changes in the path, or the interval of the path length or interval of the displacement will be equal for equal intervals of time. Hence, if you are drawing a graph, xt graph for the a body in a uniform motion, you will get a graph like this. Okay, where you can see for the first second for the first second the displacement is 1 meter. For the next 1 second also, that means total 2 seconds, the displacement should here 0 to 1 it took 1 meter. Okay, it moved 1 meter. So the next 1 second also it will move 1 meter. So here it will be 2, niche 1. So 1 second, 2 second, 1 meter, 2 meter. Likewise, if you are taking the values, then you will get the graph almost like this. Now the next one, that is the motion. Of a non-uniform motion. So in that case we will have the graph like this. That means not in an order. First the time changes but there is no change in the position, then suddenly it is increasing, afterwards it is being constant. A random graph will be there for the uniform motion, okay, non-uniform motion. Okay, and afterwards we have discussed yesterday the average velocity, average speed, all those things we have discussed, and I think you have understood that one. Now we will go to the instantaneous velocity and speed. Suppose if you are considering the average velocity is the, suppose if you are having a time t1 and t2 and the position x1 and x2, you just consider the average velocity means the velocity with which the body was moved in between these two time periods. Okay, delta x or x2 minus x1 divided by t2 minus t1. ये जो टाइम पीरियड के अंदर, मतलब ये टाइम पीरियड के अंदर कितना velocity, how much fastly that position is changed. Suppose if we want to find the velocity with which the body changed its position for a fraction of distance in between this time interval, okay, just a fraction of position, or just a fraction of, within a fraction of second, how much is the velocity, how much position has changed, or the change in the position, how much meters it is changed. If you want to find that one, then you should consider the average velocity, the instantaneous velocity. Okay, now let us come to the definition of the instantaneous velocity. Instantaneous velocity gives how fast the object moves at different instants of time during a particular time interval. Okay, actually the average velocity is the velocity for a time interval, isn't it? That means the velocity per unit time. Now if you want to get the velocity for an instant of the time, the time interval, instant of a unit time, a fraction of second, if you want to find the velocity for that point, then it will be known as the instantaneous velocity. अभी 1 second मतलब if you are representing 1 second distance like this, then for a fraction of a second it is almost near to 0. Okay, almost near to 0. मतलब ये पहले वाला line, suppose if you are taking the first line as A and the second point as B, then the velocity in between the A and B, okay, that is known as instantaneous velocity. Okay, otherwise, in other words, we can explain or express the instantaneous velocity as instantaneous velocity provides us the velocity v at a particular time t. Okay, average velocity is the velocity for a time interval, but if you want to find the velocity at a particular time, a fixed time, okay, for that purpose you should find if you want to find the velocity at a particular time, then that velocity is known as the instantaneous velocity. Okay, average velocity is the velocity in between a particular time interval, and the instantaneous velocity is the velocity for a particular time, not a time interval. Okay, so remember these points. Now let us go to the next slide. Okay, the velocity at an instant is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. That is, delta t is almost equal to 0, or a value which is very close to 0. Okay, now if you are having the position, that is x2, initial and final position x2 and x1. x2 is the final position, x1 is the initial position, and the time duration for that travel as t2, the final time it is t2 and initial time it is t1, that is t2 minus t1 is the time duration for the travel. We have already discussed yesterday that if these values are given, then you can find out the average velocity as delta x by delta t, that is x2 minus x1 divided by t2 minus t1, isn't it? So if you are having these values, then easily you can find out the average velocity. Okay, in this average velocity, if you are applying a limit, that is the delta t tends to 0. Okay, limit of delta t tends to 0. That means that the delta t is approaching 0. It is almost equal to 0 or very close to 0. In such case, the delta, if the delta t is, if it is equal to 0 or almost equal to 0 or very near to 0, then the average velocity will be expressed as dx by dt. Okay, as a differential equation, dx by dt. You may not familiar with this differential equation in the mathematics chapters. You will means in the next year you will study the differential equation and all those things. But now you just understand that is the dx by dt means the rate in change of the position per the rate in change of the time. Okay, that means the rate in change of position by rate unit time, that is known as dx by dt, where dx is the very minute, very small. Actually delta x means a large distance is x2 minus x1, that is the delta x, where if you are considering very small distance, okay, then it will be represented in form of dx, and such a very small time which is almost equal to 0, that is represented in dt. So this dx by dt is known as the instantaneous velocity. So if you are provided with the average velocity, then you have to apply a limit of delta t tends to 0. That means the time should be considered almost equal to 0 or almost near to 0. Then you can obtain the instantaneous velocity value. Okay, so instantaneous velocity is the velocity for an instant of time. Okay, for a fraction of time, or we can say the velocity at a particular point or particular time is known as instantaneous velocity. I think this much things are clear for you. Now with the help of the graph we can explain that one. Okay, so in the yesterday session we have discussed, if a graph is given and if you want to find out the average velocity, you have to just take 2 points, consider 2 points in the graph, and you just join those one. Likewise you have to draw a line which is parallel to x-axis from one of the point, and from another one a line should draw a line, begin a line from that point which is parallel to the y-axis, isn't it? So suppose if you are considering the P1 and the P2, you have to draw the line like this, where this P1A is actually the line which is parallel to x-axis, and P2A is the line which is parallel to the y-axis. And if you want to find out the average velocity, then P2A divided by P1A will be the average velocity. Means the position x2 at P2 and position x1 at P1. This distance you have to, that means P2 minus P1, or we can say P2 minus A, divided by the time at A minus the time at P1. Okay, such a way we are finding out the average velocity. Now P1 and P2. Now we are just reducing the duration of time. That means in P1 and P2, P1 is almost at 3 and P2 is almost at 5. So the delta t was equal to delta t was equal to 2. Now we are just considering the delta t as one. Okay, for that we are considering 2 points q1 and q2. q1 is at the time 3.5 and q2 is at the time 4.5. We are just reducing the delta t value. You know that whenever the delta t is become almost equal to 0, then only, or almost near to 0, then only we can obtain the instantaneous velocity. So in q1 and q2 the difference is 1. Okay, so again the time duration is reduced. Now we are tending the time to 0. Okay, for that you are considering the delta t we are tending the delta t to 0. So if you are considering a point P, okay, here the P is over here, the P is here. Now if you want to find out the velocity at the point P, Okay, then you know that the x2 is at t1 is at p and t2 is at p, so it is almost near to 0 or almost equal to 0. A slight variation is there. Still we are considering a slight variation, because if the time it is not changing, that is if it t is exactly if it is equal to 0, then we cannot find out the velocity. Okay, so if you want to find the instantaneous velocity at a point p, suppose you have to draw a tangent on that curved portion and the slope of that tangent. Okay, that is, you have to just the ends of that slope is t1 and t2. You have to just join that t1 and t2 and you have to find out the slope. Okay, that is, suppose I am just drawing over here. This is the p is over here, so I am just doing a slope and I have to find out the slope tangent I have drawn. I have to find out the slope of the graph. So here it is t1, here it is t2 and here it is a. So we are finding out the instantaneous velocity. Okay, so t2a divided by t1a will be the slope of the graph, and that will be the instantaneous velocity at the point p. Okay, now let us come to the table number 3.1. So you can see the same thing that we have expressed in the way of in a graphical method, in a calculated way, mathematical way, it is given here. So first the t1 and t2 values are 3 and 5. Their delta t value was 2. The position x that at t1 was 2.16 and t2 was at 10. So delta x will be 10 minus 2.16, that is 7.84. So the average velocity value delta x by delta t will be is equal to 3.92. Okay, you can see whenever the values are whenever we are going downwards, you can see the significant figures or the preciseness of the value is increasing, isn't it? The number of significant figures increasing, as well the preciseness of the value is increasing, isn't it? Okay, now the second case, the delta t value is getting 1. That means from delta t 2 it is moving to 0. Delta t 2 1 5, it is decreasing, that means it is tending to 0. Now in the second case 1, where the t1 and t2 values are 3.5 and 4.5, and as well the xt1 and xt2, the position at the time t1 is 3.43 and t2 it is 7.29. then delta x will be 3.86 and delta x by delta t value will be 3.86. now likewise it is decreasing. Then the next case delta t is 0.5 and again 0.1. in the last case, we have to consider the last case where the delta t is 0.01. it is almost near to 0. Okay, so if you are finding out the average velocity at this time, that means 0.01, the average velocity will almost equal to the instantaneous velocity, isn't it? Because delta t is almost near to the 0. So where the t1 is 3.995 and t2 it is 4.005. Okay, then xt1 xt2 values are given, the position at those times, and delta x will be 0.0384. then delta x value will be is equal to 3.8400. Okay, so whenever the time duration is, if you are considering the time duration very small, or for a particular time if you are finding out the velocity, that is known as the instantaneous velocity. And likewise we have to consider the instantaneous speed also. Instantaneous speed, actually the instantaneous velocity is having the magnitude as well the direction, that with the help of the negative and the positive signs, the direction also can be expressed. Okay, so in this case of the instantaneous speed, the magnitude will be equal to the instantaneous velocity, but there will be no direction for the instantaneous speed. Whatever the value of the instantaneous velocity, that will be the value of instantaneous speed, but there will be no positive and negative signs. So you can say instantaneous speed can be equal to instantaneous velocity as well. Maybe it can be more than the if you are considering the positive and negative signs. Suppose if the instantaneous velocity value is minus 24, then the value of instantaneous speed will be 24, only 24 meter per second. So you can see minus 24 meter per second is lesser than the 24 meter per second, isn't it? The magnitude is equal only, but due to the sign, the value it is lesser. So instantaneous speed can be equal or greater than that of the instantaneous velocity value. Okay. Now one example is given. The position of an object moving along x-axis is given by x is equal to a plus bt square. So the position value it is given x is equal to a plus bt square, where a is equal to 8.5 meter, b is equal to 2.5 meter, second raised to minus 2, where the b value it is actually acceleration. Okay, and the t is measured in seconds. What is its velocity at t is equal to 0 second and t is equal to 2 seconds? What is the average velocity between t is equal to 2 seconds and 4 seconds? It is a question. So we know that v is equal to dx by dt. X value it is given a plus bt square. So we have to find the d by dt of a plus bt square. So a is a constant, so d by dt of a will be is equal to 0. As well, d by dt of bt square, where b is a constant, so b will remain as it is, and the t square, d by dt of t square, that will be 2t. So 2bt will be the answer of d by dt of a plus bt square. So 2bt, suppose if you are substituting the values, you will get the 2bt as 5.0 into t 5.0 into t meter second raised to minus 1. Now at t is equal to 0, v will be also 0, because 5 into t, where 5 into 0 will be 0, and at t is equal to 2 second, v will be 10 second. 5 into 2, 10. Okay, so now you have to find out the average velocity for 4 second and 2 second. So x at 4 second minus x at 2 second divided by 4 minus 2. Okay, x2 minus x1 divided by t2 minus t1. Now you have to substitute the equation. First you have to use the equation that a plus bt square, for x is equal to a plus bt square. You have to use that equation and find x at 4 second and x at 2 second. Those that will be is equal to a plus 16b and a plus 4b. So a plus 16b minus a plus minus or bracket a plus 4b will be is equal to a plus 16b minus a minus 4b. So that will be is equal to 12 into b. So 12 into b divided by 2 will be is equal to, 12 into 2b will be there. So 12 into 12 into b will be there. 12 into b divided by 2 will be 6 into b. So b value it is given 2.5 meters second raised to minus 2. So substitute that value, then the average velocity will be is equal to 15 meter second raised to minus 1. Okay, so thank you.